Hi, we are Silvana Ferro
and Santiago Vargas,
and we are going to talk about diodes.
mainly about the photodiodes and the laser diodes.
Table of contents. First, we are going to talk about what is a diode, so we give the definition of the diode.
Second, we're gonna talk about the photodiode, so we're gonna give the definition, the types, the operation modes, and the application of this diode.
And third, the laser diode, and we are going to explain what it is, how it works, the applications and types of this type of diode.
First, what is a diode? It is a semiconductor device that essentially acts as a one-way switch for current.
It allows current to flow easily in one direction, but severely restricts current from flowing in the opposite direction.
What is a photodiode? It's a semiconductor device with a PN junction that converts photons or light into electrical current.
In the left side, we can see the symbol, which is the same as a normal diode, but with two arrows on the top.
Types of photodiodes. First one, the PN junction. This is the most basic of diodes.
Second, we have the thin photodiode that instead of placing the p and n layers together to create a depletion region, an intrinsic layer is placed between two doped layers.
Third, the PDA used impact ionization avalanche effect to create an internal gain in the material.
Then we have the symbol of each photodiode.
First, we have the PN junction that is the same as the normal diode with the two arrows on top.
Second, we have the pin photodiode symbol, which is the same as a normal diode but with a P on the top.
Then we have the PDA diode, so the symbol is the same as the standard diode, and that's all of the three different types.
Working of a diode. The depletion energy will have built in an electric field.
Due to that electric field, electrons hold pair move away from the junction.
Hence, holes move to the anode and electrons move to the cathode to produce photocurrent.
Methods of excitation of protons: intrinsic excitation and extrinsic excitation.
Modes of operation. First, we have the photovoltaic mode unbiased, that is also called a zero bias mode.
Second, we have the photoconductive mode reverse biased. In this mode, a photodiode will act in reverse bias condition.
Characteristics of a photodiode. Operates in reverse bias condition.
Reverse voltage are plotted along x-axis in volts and reverse current are plotted along y-axis in microamperes.
Reverse current does not depend on reverse voltage.
When there is no light illumination, reverse current will be almost zero.
The minimum amount of current present is called dark current.
Once when the light illumination increases, reverse current also increases linearly.
Connecting a photodiode in an external circuit. A photodiode operates in a circuit in reverse bias.
Anode is connected to circuit ground and cathode is to positive supply voltage of the circuit.
When illuminated by light, current flows from the cathode to the anode.
At the left side, you can see how the current flows in the circuit. There are many kinds of applications for the photodiode. First one.
We have in safety electronics like fire and smoke detectors.
Second, you can see it on the TV units and in numerous medical applications like instruments to analyze samples.
And third, they are used in cameras as photosensors.
Fourth is used in CNATors, charge coupled devices, photoconductors, and photomultiplier tubes. Here you can see a real photodiode. This is an example.
Now we can see the datasheet of the photodiode, in which we can see the forward voltage, the breakdown voltage, and also the dark current that this photodiode receives. What is a laser diode? It's a semiconductor device similar to a lighting emitting diode, which is called also LED.
It uses a PN junction to emit coherent light in which all the waves are the same frequency and phase.
Then we can see the symbol, which is the same as a normal diode, but with two arrows pointing to the right.
How does a laser diode works? First is divided in 3 steps. The first one is energy absorption, second is spontaneous emission, and third one is
simulation emission. Energy absorption. When a certain voltage is applied at a p-n junction, the electrons absorb energy and they transition to a higher energy level. Then we can see the example of this step on the right hand.
Second, spontaneous emission. As the electron falls from higher energy level to a lower energy level, the difference in energy is converted into photons or electromagnetic radiation. At the right, we can find the example of this spontaneous emission.
Simulated emission. A partially reflection mirror is used on either side of the diode so that the photons released from spontaneous emissions are trapped in the p-n junction until their concentration reaches a threshold value. On the right hand, we can see an example of this simulation emission.
Types of laser diodes. First one, the double diode. An additional confinement layer of 2 different material is sandwiched between the 2 types, the p-type and the n-type material. Each of the junction between different materials is called a heterostructure.
Second, we have the quantum well diode that has a very tiny middle layer which acts as a quantum well. The electrons will be able to use quantum energy levels when transitioning from higher energy level to lower energy level.
Third, separate confinement heterostructure. In the separate confinement heterostructure laser diode, another 2 layers are added over the 3 initial layers. These layers have a lower refractive index, helping confining the emitted light effectively.
BCSEL. In vertical cavity surface, emitting laser diodes, however, the optical cavity is along the axis of current flow.
There are other types of laser diodes. Here we have the quantum cascade, the interband cascade, distributed drag reflector, distributed feedback, and external cavity diode.
Characteristics of a laser diode. Monochromatic, an insubstantial width of radiated narrow light containing only a single color.
Well directed. In this type, the light will be directed in a narrow beam. It is easy to be launched through an optical fiber.
Coherent, a light with a single wavelength emitted by a LED with a wide wavelength.
Doesn't operate until a minimum power is applied. If the light is below this energy, then the emission is weaker than the threshold compared to the full energy.
Applications of laser diodes. Consumer electronics,
Medical machines,
autonomous vehicles,
scientific instrumentation,
industrial applications.
laser diode component. Here we can see a real-life laser diode.
Laser diode datasheet. Here we can see the forward current, the reverse voltage, and the forward current that this laser is capable of receiving. Thanks for watching our video.
We hope you learned something about these 2 different types of diodes.
And we see you in the next time. Please subscribe! ¡Excelente!
Casi.
Respira todo duro él. Casi nada.
Y la batería.
An insubstantial well.
Estaba como. Mamá. Sí.
Thanks for watching our video.
Me estoy con la nariz. Are the same frequency and phase.
The same. Te iba a decir la same.
Ella.
One light emitting.
For the photodiode.
Photodiodes in the positive.